Sorry I had to cut that other video short real quick, but continuing along. So I'm going to follow that same process again. I'm going to just do it a little bit quicker to solve for W. So step one is already done because, well, we did it last time. But now for step two, determining which trig function we're going to use. This time I'm looking for the adjacent and I'm using the hypotenuse. So cosine is the function I'm going to use. Cosine is equal to adjacent divided by hypotenuse. Step 3, substituting the numbers, theta is 36, and variable, adjacent is w, hypotenuse is 17. And we have the situation once again where the variable's in the numerator of the fraction. So we're just going to multiply both sides by the denominator number to get the variable alone. W equals 17 times the cosine of 36 degrees. And we enter that in our calculator. Now, by the way, I should have said this in the last video. If you don't get this value when you type in 17 sine 36, you may have a backwards calculator. And backwards calculators are kind of annoying, but once you realize that it's a backwards calculator, you can still get the right answer. Backwards calculators, you have to type it in backwards, basically. You would do the angle, then the trig function, then hit enter, and then multiply by the coefficient out front. Most calculators are not backwards calculators, but some of them are. 17 times cosine of 36 degrees is approximately 13.8. And once again, we're in centimeters. Now, these are right triangles, so once you actually have two of the three sides, one side would have been given to you, 17, and maybe I just found r as approximately 10.0. I could have actually used the Pythagorean theorem to get this other side, so we can still use the Pythagorean theorem. Alright, in this example, this time the angle is in the top left-hand corner. So when I'm doing step one, assigning sides, we still have the hypotenuse opposite the right angle, but this time this vertical side, which was opposite in the last example because I used this angle, this time the vertical side is the adjacent side because I'm using that acute angle up there. W will be the opposite. So now maybe I will solve for r. So the trig function I'm going to use, let's look at what I have and what I'm trying to solve for. I know the adjacent side, I'm looking for the hypotenuse. Cosine is the function that uses adjacent and hypotenuse. So I'll go ahead and write that definition down. Cosine theta equals adjacent divided by hypotenuse. Step 3, substituting the numbers and variable from the problem. Cosine of 58 degrees equals 8 feet over r. And here we have this second scenario where the variable we're looking for is in the denominator. So I've generalized here the shortcut, but let me deduce it out for you real quick. We'll multiply both sides by the denominator. This gets rid of our fraction. And then, to get r all by itself, we can divide both sides by the trigonometry function. And I get r equals 8 divided by the cosine of 58 degrees. Go back to our good friend, the handy-dandy calculator. 8 divided by cosine 58, and we get approximately 15.1. Now I'm going to show you a little trick here. So 15.1 is great for a final answer. I'm going to use the Pythagorean theorem now, actually, to get the value of W. We don't want to use 15.1 though, because that number is rounded, and if we square some rounded number, we're going to square our rounding. So what I would suggest is either one of two things. Either write out the number to a few more decimal places, at least 3, 4, 5 work better, or even better than that, don't even clear it out of the calculator. Just square that number. Okay? This is the hypotenuse. So we square that, and then using the Pythagorean theorem, we'll subtract the square of this other side, and then we will take the square root of that number, and approximately 12.8. Could have got there with trig also, but it is a right triangle, so use the Pythagorean theorem once you have two of the sides. Just don't round early. That's the only problem. Don't round too early. Use more decimals than 1 so that your answer will be accurate, or just don't even clear it out. The last example here is when we're solving for an angle, but the procedure is pretty much the exact same, just this simplification step is going to be a little different. So, step 1, assign sides. Okay, going to find R. So, this side is going to be adjacent to angle R, and 7 is going to be the opposite. And then step 2, which trig function? Which trig function uses adjacent and opposite? That will be tangent. So we'll go ahead and write down that definition. Tangent of theta equals opposite over adjacent. Step 3, we're going to substitute our variables and number. This time R is theta, the unknown, and the opposite is 7, and the adjacent is 3. The units factor out. And now we run into something that I need to describe to you, and that would be the inverse trig functions. They're usually the second function of the button itself, so it might be a little difficult to see, but let me zoom in and let me focus. Oh yes. So if you look here at the sign button, right above it is sine to the -1. That is inverse notation. And we use inverse trigonometry to cancel out the trigonometry function itself. So that if I have this equation, tangent of r equals 7 over 3, and I want to get r by itself, we can take the inverse tangent of both sides of the equation. And when you compose an inverse trig function with the trig function itself, they cancel out. Now, I might be oversimplifying this. When you get to pre-calculus, there's a few more things to know. But for freshman geometry, that's good enough. To cancel out a trig function, if the variable is attached to it and you want to get the variable alone, it's not like multiplication. You're not going to divide by tangent. You're going to compose it with its inverse. And now I get r equals the inverse tangent of 7/3. These parentheses are super important. Second tangent, and that's where we get the inverse. 7 divided by 3. And we get our lovely angle. Angle R here is 66.8 degrees. So R equals 66.8. That means this angle right here is 66.8 degrees. Now, it's a triangle, so yes, I could use trigonometry again to solve for this little angle, but it's a triangle, so the two acute angles have to add up to 90 because all three angles have to add up to 180. So you can just use the, once you have one acute angle, you can just find its complement to get the other angle. And that is how to solve for all of the side lengths and angles using right triangle trig ratios. Fun times.